Okay, welcome to our next video here for Chem 161, Chapter 1 content, discussing SI base units. And metric system. Prefixes. Okay, so if you look at the Chapter 1 slides available on the course, around slide 35 you will see a reference to Table 1.2 from your textbook. This is an important table because it lists the 6 SI base units that are commonly default for reporting scientific quantities or dimensions. Okay? And so the S and the I stand for the first letter of the group that led to the discussion, that led to the table, which was the Système International d'Unité, French group that got together and decided to standardize how information was going to be communicated in the sciences, based out of a discussion in France. And so the idea here was to standardize information for mass, length, temperature, etc. Okay, so you'll see here that this table largely lists quantity or dimension as the first column. Next, there's the unit name. So let's start with some of these to go as we complete our table. So for example, a quantity or dimension could be mass. The unit name that we're going to use here is going to be the kilogram. And the unit abbreviation is going to be lowercase k, g. And to give you some reference, we'll put here an extra category here that is the sort of common used information. Okay, so commonly handling stuff in maybe our high school lab, maybe you've used grams instead of the kilogram and used symbol G there. Okay, so further information in that table 1.2 is length. And here you would have from the SI units, we would use meter and again try to default information and report it out in lowercase m units for the abbreviation there. You might be used to length being more in terms of feet or maybe even miles for your everyday experiences. The next one in table 1.2 is temperature. Here perhaps you've had more experience with ambiguity and a need for standardizing information in the sciences is highlighted through the category temperature. In this case, the default unit name is going to be Kelvin. We're going to use capital K for that. And others that you may have experienced are things like degree Fahrenheit or degree Celsius, with degrees Celsius being very common in the sciences as well. Time is also another quantity or dimension, and here the default is going to be the second for reporting that type of information, and here we're going to use the abbreviation lowercase s. And others that you're familiar with, of course, are things like minutes, MIN, Notice the abbreviation there is different than miles, MI, and things like hours with HR. Okay. Table 1.2 also lists electric current with amperes and capital A as those units. We won't be using that in this course, so we'll exclude that from this discussion and instead skip to the last row of information, which would be the quantity of a substance okay. And so here is going to be a new one for you, perhaps, where we will use the mole to count groups of atoms or groups of molecules. And the symbol for this, the abbreviation for the unit, only shaves off one of those letters, and we will use MOL for the unit there. And something that reports out groups of things that you might be used to might be, for example, a dozen, which you're used to counting in groups of 12 in that case. So as we start thinking about the mole later in this course, it's a good reflex for you to draw on analogies or experiences where you've had to count in dozens and use your intuition there for how to count overall number of particles or things of interest, not in terms of dozens, but use those same ideas instead to count in terms of moles. Okay, so we'll see that the mole is not a small number like 12, but rather a very, very large number like 6.022 times 10 to the 23. Okay, so that's table 1.2, and again, it's given us our sort of default unit names for some quantities or dimensions, and we will be able to transition to many others in the metric system according to the prefix information and some information for the multipliers that are listed there. Okay, and so table 1.1 helps us out there. Where we'll see that we have a prefix, typically with typical kind of prefix information like zeta, exa, peta, tera, giga, mega, kilo, a lot of different options down there. And you can see here how the numerical multiplier goes from very, very large numbers to very, very small numbers. With things like the deci being a tenth of a unit, or the deca being tenfold of a unit. And we'll see those sort of multiplier information reflected in a scientific notation type value as well. Okay, so while table 1.1 is very comprehensive, instead we're going to build another table here which represents what you're responsible for Chem 161. So in other words, you'll have to modify table 1.1 to see what you're responsible for memorization. Okay, so we'll start here with, again, making our own table. We'll put the prefix out at left. Let's start with something that might be the largest for what we're responsible for. So we'll go with giga. The multiplier on that, or the multiple that we're going to use there, is going to be 10 to the power of 9. So that's a billion. And we're going to put a symbol for that. And the symbol for that is going to be capital G. Okay. The next one we're responsible for is going to be the mega. That's going to be 10 to the power of 6. And we're going to use a capital M there. Next one is going to be the kilo. That's going to be 10 to the power of 3. And that we'll use a lowercase k. Our next one is going to be the deci. That's going to be 10 to the minus 1, and this is a lowercase d. Our next one is going to be the centi. This is 10 to the minus 2, and we're going to use a lowercase c there. And our next one is milli, 10 to the minus 3, and a lowercase m for the symbol there. Thereafter, we'll use the nano. This is now 10 to the, apologies, I missed one. Missed micro. Micro is our next one. This is 10 to the minus 6. And here we have a newer symbol that we have to memorize is mu. It looks like a U, except it's asymmetric. The tail at left is sort of longer, and the sort of tail at right is kind of more horizontal than we would see in U. So this is symbol mu to represent micro with a multiple of 10 to the minus 6. Now we're into nano, and we'll have a 10 to the minus 9 here, and we'll use symbol lowercase n. We'll have pico. This will be 10 to the minus 12. We're going to put a P there. And one more that we'll be responsible for here is going to be the angstrom. This is 10 to the minus 10, and it's also given an interesting symbol. It's going to be capital A with a little circle hat on top. And the angstrom, in terms of distance, angstrometers or angstroms, is very common when we describe distances in molecules. So bond lengths are typically best described with ultimate numbers that are between 0 and 1 or 0 and 10 when we use units like the angstrometer for that. Okay, so while it's a big list, you can see probably half of these you've already memorized. And so you should be very much prepared to memorize the ones you don't have experience with yet, and ultimately construct conversion factors to help us here. So let's just touch on that quickly here, on how you would use a table like this to help you with some conversion factors. So one way to do this is to modify the table here to show some scientific notation to determine some identities. So let's start by modifying the multiplier to look more like scientific notation. Well, I can multiply anything by 1, so we can start doing that. 1 times 10 to the 9 now looks like scientific notation. That is still a billion. And if we want to talk about units, say, in the case of distance, so we'll look at using the meter. Let's now say 1 times 10 to the 9 meters has to be equal to something. Well, that's going to be equal to 1 gigameter in that case. So there we have our first identity. 1 times 10 to the 9 meters is equal to 1 gigameter. Okay, so we can continue that pattern down the way here and do a couple more examples. Let's jump down to the millimeter. 1 times 10 to the minus 3 meters is equal to 1 millimeter. So while the two symbols here are the same, lowercase m for both, the last one is indicating the type of quantity, so that would be the length. The first one is indicating the prefix for the multiplier, that is 10 to the minus 3. Let's keep going down. Maybe use the angstrom one. 1 times 10 to the minus 10 meters is equal to 1 angstrom. Okay. So here you see we drop the lowercase m to indicate the distance of angstroms for this distance here. Kind of a special one there. Okay, and then moving back into more regular ones, let's use the Picot next. So 1 times 10 to the 12 meters is equal to 1 picometer is another option there. Okay, so there's some examples there. And hopefully you feel a little bit more comfortable with these. So if you had to generalize what we've done here to use for other quantities or dimensions, we simply modify the units in question. So we can get rid of all of the m's and replace them with any other quantities or dimensions of interest. So let's do that. And instead consider, for example, mass units starting with grams. Okay, so 1 times 10 to the 9 grams is equal to 1 gigagram. 1 times 10 to the minus 3 grams is equal to 1 milligram. 1 times 10 to the 12 grams is equal to 1 picogram. Hopefully you see the pattern there. Okay, so we'll end it there. Again, the table, the modified version of table 1.1 and how to use it, as we've shown here, is a key requirement for you. You must memorize the information here and how to use it. And we also must be used to using these common SI units. And we'll do lots of examples here. And we'll see more on the quantity of a substance later in the course. But as a bit of a preview, we have